In this video, we're going to take a look at creating some segment and angle constructions. A big part of geometry is investigating various geometric shapes, segments, angles, triangles, and other shapes as well. But a big part of that also is being able to create these things and explore some of their properties. So in this activity here, we're going to get a preview of some of the tools that we'll be using later on to make these things. You'll notice that there are some directions highlighted here in the activity itself, but if you follow along in this video, I'll show you how to create these as well. So the first thing we're going to do is make a congruent segment to this one. And a big thing when we create segments is we want to make sure they don't turn. So in our construction, we're going to start with a line here. And it doesn't really matter where it goes for two segments to be congruent. That just means they have the same length. So I'm not putting C and D right now to try to make them the same spacing as AB. Rather, I'm just going to spread them out to give myself some room to work. So to create equal length, we're going to use a circle, a compass tool on here. You notice the compass tool shows a marking from the center of the circle to the outside, and that represents the radius. And one thing to remember is that in a circle, the radius is never changing. So from here, the radius would match to a different part on the circle. So when we use this circle, this compass tool here, I can click on these 2 points, A and B. And you see I get a circle, and this circle has a radius that goes from A over to B. And so as I move this circle, the radius doesn't change. I can bring it down to B, and it extends to A. So the radius is consistent as I move, meaning if I were to move this circle somewhere else and draw another radius, I'd be making a segment just as long as this one. Well, that's why I have this line over here. I have a couple points to choose. I'm just going to choose C. It's nice and close. And now that I've placed this circle here, what I can do is I can create a new radius. I'm going to use the intersect tool here, which identifies where two objects cross each other. And points of intersection are going to be shown in gray on here. And so if I connect from C to F with a segment, I should be creating a segment just as long as AB. Okay, now that I've created that segment, I'm not going to click on anything else. You know there's a customization toolbar up here. If I click up here, I can change the color of that segment to green. And it's still kind of hard to see. So I can also come here and change the thickness of this line. Now I'm just doing this to point out my new construction to compare it to the original. And so right there is a very simple way to make a congruent segment. It doesn't have to be in the same orientation, but it is the same length. Okay, so let's try that with another. In construction 2, just a chance for us to do that again for extra practice. So once again, I'll start with a line to make sure the object that we create doesn't turn. And it doesn't matter how far apart these are. We're not trying to make the segment yet. But now that I have a line to work with to guarantee our new shape doesn't turn, let's copy this segment. Let's make another congruent segment. So if I make a circle here, clicking on A and B, notice this circle has a radius that goes from A to B or B to A. So as I move the circle, the radius doesn't change. Meaning if I move the circle up here, the radius has not changed. And I can show using the intersect tool where the circle crosses the line. And if we make the segment from C over to this point F, that is a radius that should be the exact same length as AB. Okay, so I'm going to change the color and change the thickness so that we can see it a little bit better. And there we go. And so right there, we've created a congruent segment. And that's the idea with constructions here is I don't know how long these segments are, but I do know they are the same length. Okay, and that's the whole idea of constructions, making these things without actually knowing their measurement to start. To verify that though, I did add in a tool just to show that we're doing it correctly. So if I click on this distance or length tool here, and I click on AB, it tells me it's 5.44, and CF should end up being the same. And good news, it is. Okay, so let's try a couple more scenarios with segments here. One of those being this. We're going to make a segment twice as long as the one that we're shown. So again, we are going to make a brand new segment, and I want to make sure this doesn't turn. So I'm going to use the line tool here. And putting these points down, spacing does not matter. Okay, so if we're going to make a segment twice as long as this one, essentially I would need two of these. I need two of these links of A to B. A couple ways to do that. One way is create your circle and bring it down to C. If you do that, the understanding is from C to this point, F, is the same length as A to B. Well, that's not twice as long yet. And so to make it twice as long, all we need to do is use that circle again. We need another radius. So if you go to the compass tool here, if you actually just click on the circle, it makes a copy of it. What I'm going to do is I'm going to come down to point F and center that there. And let me show the point where this intersects as well. And here's what we need to understand. A to B was the radius of our circle. Well, C to F was a radius of the first circle we used. F to G was the radius of the second circle that we used. And since those circles are the same, we have one radius and a second one as well. Well, what's twice as long as one radius? Two of them. And so if I create a segment from C over to G, change the color here to get a better view of it, change that thickness, okay, make it stand out. So what we're claiming is that C to G is twice as long as A to B, and we should understand that because we have one radius, two radii, plural of radius there, which is twice as long as just the one radius. And again, we can check that to verify, which is not the purpose of constructions, but we're learning here, so we want to see that we're doing things accurately. A to B is 3.3. GeoGebra does round a little bit. Typically only goes out to 2 decimal places, so it is possible that this isn't exactly 3.3. It could be like 3.304 or something like that, and we're going to see that happen down here. When we click on C to G, it's not exactly 6.6, it's 6.61. So whatever this was, it was a little more than 3.3, which made it round up to 6.61. That was an easy way to do this. Another pretty simple way would be to just use one circle and draw a diameter across it, which is essentially what we ended up doing anyway. If you remember from previous geometric discussions, the diameter is twice as long as the radius. So that was another approach. Okay, and in our last construction over segments, what we're going to do is we're going to create a new one. You notice here it says use the 2 segments below to construct AB plus CD. So in other words, construct the sum of these 2 segments. In other words, if we make a segment that's going to be the length of AB plus CD, it's going to be a longer segment than either one of these because it's a combination of the 2. So again, with segments, we don't want them to turn. Let's construct a line here. It's going to make points F and G for me. Okay, and this is going to require 2 circles from us. The first, I'll use our compass from A to B. Okay, so the radius of this first circle is for the shorter segment, AB. So I'm going to bring that down to F, and I'll show where the circle intersects. And so the idea here is that from F to H is the same length as A to B. So what we need now is the longer segment length as well. And so again, A to B is the same as F to H. And so we have that taken care of. We still need the CD length. And so we need a new circle here, measuring from C over to D. So the radius of this circle goes from C to D. Okay. And as we move the circle, that's still true. The radius of the circle is still that length. So if I bring this down to point H, we're going to think about this. If I bring this down to H and create a new point over here, we have 2 things. From F to H, that is the length of A to B. From H over to I is the length of CD. So as I start creating a segment here, this segment, FH, is for AB. And then we're going to continue on with H to I, which is our length of CD. And so this segment's getting longer and longer than either one of those because it's the combination of the two. And so if I make a segment from F to I, let me change the color here. This new segment should be a combined length of the two that we started with. Well, let's verify that one more time. We have distance, so let's check A to B. That's 3.3. C to D is 5.97. Combine those two things, add those together, and you should get 9.27, which hopefully is what we get when we click on F to I. There it is. And so we see a way there to create a new segment based on two others. Okay, so that's the main thing we're going to do with segments at the moment. Now let's talk about angles. Angles are a little bit trickier. Remember, an angle measurement's based on how far apart the sides are. And you see here there are steps again. There are more steps here than there were for segments because there's more to an angle. It takes two segments or two rays to make an angle. So we have to do about twice as much work. So you can read through these steps. I'll also show you how to do this here. So task number 5 here is to copy this angle, make a congruent angle to angle CAB. So again, the idea with an angle is it has a measure based on how far apart the sides are. So this angle appears to be acute, less than 90, because of the spacing here between this segment and this one. So if we want to make a angle congruent to this one, we're going to need to recreate this spacing. So to do that, we have to do a couple things. One issue we have is, well, really, here's the task. If we can place these 3 points in the same locations over here, we're ready to go. The problem that we have right now is we don't know if A to B, the spacing from A to B is the same as A to C. And so the first thing we need to take care of is that guaranteed spacing. So rather than using these 2 points that I don't know the lengths of, those segments, we're going to make a new set of segments here. I went to my point tool, and I'm going to make a point down here between A and B. It doesn't matter where. If you put it in a different spot, you're going to get different size circles than I will, but we'll still end up making the correct angle. So I'm going to put F here. And when I go to the compass, I'm going to go from A over to F. And I'm going to center this circle at A. And remember, in a circle, the radius doesn't change. And so what I'm doing right now is I am going to show 2 segments of the same length. So let me go to this intersect tool and click right here where these are crossing and talk about these 2 segments, AF and AG. We know they're the same length because they're both the radius of a circle. And let's make a copy of this circle and bring it over here to D. Because what I'm going to do is start recreating these points. So I recognize that A and D are corresponding. They're both going to be the vertex of our angles. And A reaches over to F down here. Well, that was a radius of the circle, so I can show a radius of the circle over here as well from D to this point. So D to H is the same as A to F. So I've recreated those 2 points. And if I can just recreate the third, I'll be ready to show our new angle. So the third point that we made over here was G. I just need to figure out where G goes. And I don't yet. I know it goes on the circle, but where I put it matters because where I put it determines whether it's acute, right, obtuse, and it'll change that measure. So to be more precise, what we're going to do is we're going to make a second circle, and this one is going to measure the gap of our angle, how wide of an angle we have. And to do that, we just click on these 2 points that we made, F and G. So the radius of the circle goes from F to G. And if you notice right now, this new circle, when I put it on F, this new circle goes through G. And the original circle also went through G. So both of these circles go through this point that we still need. Well, I already put the first circle over at D. If I bring this new circle over to H, which corresponds to this point F, I'm going to have these 2 circles that are going through that point G. And so if I show the point of intersection right here, this new point is the point that's on both circles, just like we said about point G. And so if we make our segment here from D to I, we should get an angle congruent to the one we had before. Let me make another one here. I'm just highlighting the new angle that we made. So the thought here is that this new red angle is the same measure as the original angle we made. So let's go and try this again. Another construction of a congruent angle. This time it looks a little more obtuse and opening in a different direction. So again, if we can just recreate 3 points from here over to here, we'll have this angle that has this gap. And again, we want to bypass any issues. We want guarantees only, and we don't know if it's guaranteed that AB and AC are the same length. So like we did last time, we're going to create a new point here between A and B. And we're going to use our compass to measure from A to that new point, because when we go and show a new point here where the circle meets the segment, we know for certain that AF and AG are the same length. They are congruent segments because they're both a radius. And so all we need to do is recreate these 3 points over here. Well, we already have one of them. A is serving the same purpose as D. Okay, so we just need to figure out where to put F and where to put G. Well, one of those is pretty easy. It's easy to get started. Let's take this circle and bring it over here. And let's show where the circle meets the ray. And so what we have right now is we have a segment that's congruent to AF. So segment AF and DH are congruent to each other. So we have that taken care of. We have these 2 points, D and H, that are representing the points A and F. So we still need to figure out where to put G. We know this circle that we brought over has G on it, but where we place it could change the angle measure. So what we do is we use that second circle to measure another gap that involves the letter G. So this new circle that I'm making, notice it also goes through G. Meaning these 2 circles over here, they both go through G. And so if I bring this new circle over here, I'm going to keep that understanding that these 2 circles are both going to go through G. Now you notice that this new circle goes through the previous circle in 2 different places. And so you might ask yourself, does it matter which one we use? And the answer is no, because an obtuse angle doesn't have to open downward. It could open upward as well. That doesn't matter. So we actually get a choice here on which one we want. Maybe I'll just be consistent. I'll choose this one, call it point I. I'll make a segment here from D to I and change that color. Change the thickness here. And I will do the same from D to H. And so what we see is that this brown angle should be the same as our original. If I use my angle tool here, we can check that. So let's verify. We don't know how big these angles are. We know they look obtuse, but these steps should guarantee that they're the same, even though we don't know how much they measure just yet. If you've forgotten, this angle tool measures counterclockwise. Think which way would be counterclockwise. So to measure this, I need to start at G and end at F. And since angles are named with 3 letters, we click on A, G, then A, then F. And we see this angle has a measure of 127.52 degrees. Let's try that over here. I, then D, then H, and we see the same thing. Okay, so a few more steps than segments had, but not overly complicated. All we are doing are recreating the points in one image and bringing them over to our second. Okay, we do have one last task here. It comes with its own set of instructions, and it is simply to take an angle and bisect it. So construct an angle bisector for angle BAC. Well, Let's remember what it means to bisect. That would mean to split an angle into two equal parts, to cut it in half, in other words. Okay, so let's think of what it means to cut it in half. If I just started a segment up here and started at A, where would we be if we're cutting it in half? Not here. We'd get a really small segment and a big segment next to each other, or big angle and a small angle next to each other. Same if we're here, but if we come to the middle-ish area, somewhere in this range, looks like we're starting to get two equal angles, two congruent angles. So let's figure out a way to know exactly where it goes. So if you're going to be constructing a bisector, you have to be in the middle of this space. And so we're going to think of this equal spacing idea. To be in the middle means to be equally spaced from either end, either side. So we're going to start off like we have with the last two angle constructions, because if we're going to be equally spaced, we need to have points that are equally spaced to begin with. And we don't know if A, B, and AC are the same length here. So I'm going to make a new point, call it D. And if I construct a circle from A to D, okay, and place it here at A, we can show that second point down here, point F. And we know that A to D is the same length as A to F. So we have that equal spacing, and that equal spacing is going to help us find the middle, which is equally spaced from either side. All right, so what do we need to do now to find the middle? Well, to find the middle, we just need to find a place that is the same distance away from F as it is to D, the same distance away from this side as it is to that one. Well, we're going to keep using this idea of circles. Remember, the radius in a circle doesn't change. And so if we're able to draw a radius from both of these points here, F and D, then we're going to be in the middle. So all we need is to use a circle twice. And I'm going to make a new one. Not that I have to. It doesn't actually matter here, but I'm going to make a new circle from A to B. And I'm going to use this circle 2 times because the radius in the circle won't change. So if I place this new circle once at D, for example, okay, I know from D to anywhere at this circle is the radius. Well, if I recreate this circle, this new circle has the same radius as the one that we just used. And so as I move it elsewhere, I know it has an equal radius to the one that we just placed at D. So if I take this same circle and move it to F, I know that from F to this circle is a radius, and D to this circle is a radius. So these two radii are going to be the same length. And you notice that these two circles meet up out here. I'll place a point there. It's going to call it point G. The idea is from F to G is a radius because G is on the circle. D to G is also a radius because it's on the circle. And if those are both a radius, then G is the same distance from D as it is to F. And since we're equal distance from either side, we must be in the middle. And so what we're going to do here is we're going to construct a bisector. I'm going to use a segment here to go from A to G. I'm going to change the color to help it stand out. Change the thickness here. Okay. And what we're saying is that this orange segment is bisecting the big angle. I'm going to verify that with our angle tool. If I measure angle GAD here, we notice it says 63.76. If we do it again over here, going from F to A to G right there, we should end up getting the same measure, and you see that we do. They both say, I thought I was going to be able to drag that, but we do see they both end up saying 63.76. And again, the idea here is we did not know how big the angle was originally, but we did know that if we could find the middle, we would cut it in half, which is exactly what we did. So there are some basics of some constructions. Again, we'll end up making more as we go throughout the year, but this is a good foundation for us to start.